all. Hope all of you are doing good. So this is a first project idea with our ATTiny programmable controller. The introduction and features of this ATTiny programmable controller has been provided in another video. So to get idea about what features and what capabilities this controller provide, I do request you to watch that video. As I mentioned, this is a programmable controller with three inputs, either 5-volt DC or dry contact jumper selectable, and two relay outputs along with 80 tiny microcontroller, 6-piece 80 tiny microcontroller, which could be 85, 80 tiny 85, 80 tiny 13A or 80 tiny 13. So the first project idea which we are going to see with this uh, controller is water tank level control. So let's dive in. Before proceeding into the application, let's see first how the water level switch work. Because what we are going to do is like we are going to control the tank level, and this tank level has water level switch or controller which we are going to use. So that switch is in binary in nature. So first we will see how this uh, switch works. There are variety of switches or different type of switches available in the market on Amazon.in, or you can search online and you will get different type of switches which are having different installations methods, but most of them are having few parts common. So as we can see in the diagram, the level switch has one moving part and another fixed part. The moving part goes downwards due to gravity, and as water level rises, buoyancy force push the moving part up and let it contact with the fixed part. When it is away from the fixed part, it is either open or close. But when it touches to the fixed part, there is a maybe a magnet or some other kind of sensing element is there. So when it touch to the other part, it goes to the opposite state. Okay, so for example, when it is open or it is down, there is no water, and when it is uh, on the ground level, it could be off. But as when water level rises, and when this fixed part touches to the uh, the moving part touches to the fixed part, then it will be on. So let's see how i- through animation how it works. We can see now it turns on. When it turns on, it gives the signal or close contact signal to the controller, and then controller understand that the water level has risen. So I will show you in the video. There are variety of sensors. I have few sensors with me. So let me show you that. You can see that this is a one type of sensor, and this moving part moves upward when there is a water and falls due to gravity force when there is a no water, means then water level is low. This is another type of level switch. This can be installed on the top of the tank. It also gives the close and open, and this is another type. So anyone which is suitable to our application, we can use. These are big float switches. So we can see that as water level rises, the uh, the lower part will rise up, and there is a metal ball which will fall and make a contact. Then these are conductive type. Conductive type we cannot use in our circuit, as I mentioned that only dry contact and 5 volt DC currently we can use. So we can use with additional circuitry or additional circuitry the conductive, but most commonly we will use a close open dry contact level switch for our application. So let's see uh, a concept diagram. Most commonly we have a lower tank, or sometimes it is a submersible uh, tank. Uh, then we have pump, and then most of the homes, this is a home picture, so upper tank. So what happens is like in manual method, we turn the pump on and let the upper tank fill, and after some times we turn the pump off. There are few disadvantages by operating this pump manual. The first is like there are chances that the upper tank will overflow and there will be wastage of water if proper attention is not provided to turn the pump off. And another issue is like sometimes if lower tank does not have a water and if pump runs without the water, then the pump will damage because it will run as a dry and it will draw more current, will become hot and it will damage. And replacing cost is very high. So if we add automation to this pump, it will not only save our water by avoiding the overflow, it will save our pump also from damaging due to dry run. So let's add automation to this pump with our controller. First thing is like our controller is there. Then we will add lower level limit switch, lower level water level switch. Then we will add two level switches to the upper tank to indicate the low level and high level. And then we will provide a command to the pump. Okay, so this is our concept diagram. Now let's see the operation. So initially, if the controller senses that there is a no water in the lower tank, it will not turn the pump on even if there is a requirement. Okay, we can see that the water level in the upper tank is below the low level and it need to be filled. But as the controller senses that lower tank is empty, it will not allow the pump to turn on. So let's see first what, let's fill the lower tank. Now, as lower tank has sufficient water and controller has sensed that there is a water in the lower tank, it will give a command to the pump. And as soon as pump receives the command, it will start filling the upper tank. When upper level switch senses the water, it will turn off the pump. Now, same operation will repeat. Now there is no water in the upper tank, so it will again give the command to the pump. will again fill the water. So whenever there is a requirement of water in the upper tank and there is a sufficient water in the lower tank, the controller will fill the tank. This is a wiring diagram. As I mentioned, this controller accepts 230-volt AC. So we do not have to add any other circuit or any other means AC to DC converter or something. Straightforward, we can connect 230-volt AC. Then we can wire the level switches. There is a common ground and then pin 432 where we can wire this. For at the output, we can use the normally open and common section and loop it to the through volt AC, through the 230 volt AC. So when this is closed or turned, pump will energize. Now this pump wiring will vary as per the requirement, means whatever the requirement. This is shown for the means for the as an example, but it may differ uh, as per the installed pump panel. So that need to be verified. Okay. Now we will see the programming. As I mentioned, we will connect these level switches to the inputs and pump command. And I have also added a buzzer like which will inform the user that the pump has started or pump has closed. Sequence is already we have seen very simple. When there is a sufficient water in the lower tank and upper tank requires the water, then start the pump, and when upper tank has sufficient water, turn off the pump. Okay, so this is a program for our tank level control. As I mentioned, we have two tanks. One is at the lower level and another is an upper level. And total we have level switches. The one level switch is connected to the lower tank lower level, and another two are connected to the upper tanks. One is at the bottom side and another one on the top side. So here we declare these inputs and outputs connected to their respective pump command and pump buzzer. Here we took three variables so that we can read these inputs and pass the value to these variables. Then it will be easy for us to write a program. And here we took another variable for the pump. In the setup section, we defined the inputs and outputs like pin configurations. So the pump command and buzzer are defined as an output, and level switches are defined as inputs. Then we write down these low values, or we turn off the pump command and buzzer as we don't want them to be accidentally turned on during the startup. So this setup section will run only once when we start the unit. So we do all the initialization during this one time running program. That's why we turn the pump off, because initially we want the pump to be off and later we want the pump to be turned on based on the conditions. So in this loop section, this program will repeat forever from top to bottom. It will check the conditions and accordingly run the program. So we can see that first condition we check like whether the lower level is low, means we checked whether the lower tank is empty. If it is empty, we want the pump to be off. Yes, because we don't want pump to run when there is no water, because that will damage the pump as well as create other problems. we added the delay of 500 seconds, 5 seconds, sorry, because we turning on or turning off, we are adding some delays, 5 seconds delay, because we don't want the output to be chatter or turn on off quickly, because there are chances that level switch may get quickly on and off. Okay, that's why this added. Now, if else if means if lower tank is full and if lower tank has water, then we will check whether upper tank low level is uh, off or low level is low or what. So if low level is low means in upper tank there is no water. Lower tank is filled and upper tank there is no water. We are turning the pump on. Once the pump is turned on, the next section we will turn the buzzer only for 10 seconds. So buzzer, whenever the pump will turn on, the buzzer will turn on for 10 seconds and it will turn off. That will give indication to the users that the pump has been turned on. Now we will check the upper tank high level. If upper tank high level is high, means if water reached up to the upper tank, then we are turning the pump off. And then we are turning the buzzer on for 5 seconds and then turning it off. So timing difference will tell that whether the pump is turning off or on to the user. For example, if user listens the buzzer for 10 seconds or longer duration, he will understand that the pump has turned on. But if he listen the buzzer for only 5 seconds, he will understand that the pump is turned off. Now, whole this logic we can rewrite if there are any changes, any modifications, we can rewrite as per our requirement. So let's now download the code, or it is saying upload, means is uploading the this code into the microcontroller EEPROM. So this code is now, we can see that done uploading. So this code is now uploaded in this IC. Now we will, what we will do, we will disconnect this IC. Sorry, we will disconnect this and then remove this microcontroller, and we will insert this microcontroller in our main board. Then this board will then in demo section we will connect our level switches to the inputs and we will see actual operation. Let's see now the programming part of the microcontroller. This is our main board, which has a TThe package, so it can be directly mounted. Now it is a demo time. Oh, here is our circuit. This is lower tank low level switch, and these two are, one of them is upper tank low level and upper tank high level. As they are in the downside position means there is a no level, and when they turns up the water is filled and they sense the level. So this is like a water is up to the level switch, and this position is there is no water. So currently here also we can see that lower switch is on the downside, so there is no water in the lower tank, and these two are the relay output, and just there are indicators. So this first one is the pump output, and second one is a buzzer or any indicator light which will inform the user that the pump is turned on and on or off. So currently we can see that as lower level switch is off, so
the pump is also off. Even the upper tank is expecting the pump to turn on and fill the upper tank, still the output is not turned on. This is because there is no water in the lower tank. Now what we'll do, we will put this float switch into the water so that it will provide a signal to the controller that there is a sufficient water in the lower tank, and we can see that the pump will start. See, the pump has started and the buzzer has started. It will turn off after 10 seconds. Yes, it's turned off. So this is here at this particular output we are connecting buzzer, so that will signal the user that, oh, the pump is started. But pump is, now we can see that LED, the pump is turned on. Now what will happen on the upper tank, water will start filling. So this first lower level switch will indicate that it has a water, and now water is filling. So as soon as this upper level tank water reach to the upper level tank, we can see that pump has turned off and the buzzer output was on for 5 seconds and it turned off. Now again, let's say that people are using water. So first what will happen, upper tank high level switch will go downside, means it will turn off or it will indicate that there is a low level. And then upper tank low level switch will also, if water is continuously used, then upper tank low level switch will also go downside and the pump will start filling the tank again. But during this time, if lower level switch is off, then pump will off again. When if water is there, the pump will turn on. So this is a demo, very useful, and we can modify as per the requirement these inputs and outputs. As I mentioned that the IC is programmable.
So if you need further information regarding this controller, or if you would like to purchase, or if you would like to get programmed, if you have some applications which can fit within this controller's limitation, then you can contact us on this cell number. If we are not reachable on this cell number, WhatsApp your requirement or email your requirement on the gmail.com, and we will get back to you. Thank you for watching this video.